Yeah, that's a great question. So we think about it in multiple ways. It's a multi-layered taxonomy that does a couple of things. It actually does three things. One, we think about it from a linguistics perspective, right? From a language perspective, and so we think, how do we classify things based on words and phrases that might be interesting? We also think of it from a graph perspective, and that's what enables us to do a lot of collaborative filtering that I talked about. So it's sort of a 2 or 3 dimensional approach to that. John's going to talk a little bit about some interesting aspects of the language piece of that as well. Great, thank you.
Well, next we're having Dr. Brian Spiering, who is a faculty member of data science at Galvanize, which offers accredited master's degrees in data science.
Hey, thanks. I'm excited to be here. So I consider data science a big tent, and within that big tent, there's a bunch of different groups. And we've already heard from like the engineering camp in there. We've kind of heard from more traditional data science, you know, with your algorithms, your visualizations, your clustering. I'm going to kind of talk about maybe a different part of that camp. I'm going to talk about project management. How do you ensure a successful completion of a data science project? Because it's nice to know all the technical things, but if it doesn't make an impact in the world, the impact in the world can be limited if you don't like execute. So that's what I'm going to talk about today. So yeah, I'm Brian. I work at Galvanize. We're an education company. So if you're interested in data science education, come talk to me afterwards. I'd be delighted to talk with you. So this is how I think of data science workflow, starting with ask, then acquiring, then processing, then modeling, and then the most important step is that last step around delivery. So what do I mean by asking? What we want to do is we want to start asking the right question. So this is a process of getting the right people together and talking about the right subjects and just asking lots of questions. Do you have the data? Do you understand the data? What's your goal? What does success look like? What are possible roadblocks? The more questions you ask, the better it is. And generally at this point, you want as many people in as possible. I'm going to highlight a specific project and a specific question. One thing is we can say, how can data science be a force multiplier for good? That's really the heart of what DataKind is about, and you're going to hear a lot more about DataKind later. In particular, the project we're interested in is around flu. We're all familiar with it. For us, most of us are young and healthy. It's a minor inconvenience. Well, for a lot of people, especially the young and the very old, it's actually life-threatening. In addition, in other parts of the world, it's correlated with epidemics and possibly pandemics, which could threaten all of humanity. So even though it might seem like a minor inconvenience, it's actually associated with like deep threats, and it's actually really important to like better understand it, and data science can do that. So acquire. So that's around finding the right team and then getting the right data. And so those kind of go hand in hand in my idea. So not only do I want to have the right people, I also want to have the right tools. In particular, we were working with Skoll Global Threats Fund. So they're an umbrella organization that's interested in a variety of things that impact all of humanity. Working very closely with Adam, he's in particular interested in pandemics, and then within pandemics is flu. And then we worked with DataKind. Eric Williams was the lead data ambassador. I was kind of a junior data ambassador, just helping out wherever I could. The data that we got, we were really lucky. We had over 3 years of flu data, and this was a special kind of flu data. So the idea is that the CDC, Center for Disease Control of the United States, has flu data across the country, but they really only share that in an academic type setting or for their own work. This is actually Crowd Citizen Science. So this is an app that you can download for iOS or Android, and it is a diary type app that then pages you and asks you, do you have the flu, or does anyone else near you have the flu? And the idea is that they have this self-reported data. So it's not quite, the data that you would get from your doctor. However, there's pros and cons to that. One of the pros is that people aren't necessarily involved in the medical system. Either they don't have access to the medical system, or they don't go because they just feel like they can tough it out. And so this gives another view on that data. It's kind of a more diverse view. It is a little bit biased because of the mobile technology, but it's just another view on flu. One also thing is actually diagnosing flu itself is pretty tricky. You actually need a specialized test to make sure you have that virus. What usually they talk about is influenza-like symptoms. So do you have some combination of fever, headache, upset stomach, fatigue? So we had all of this kind of rich data. So from that rich data, you can actually see the ebb and flow throughout time and throughout geospatial about how the flu system is. Skoll did a really good job getting that app in the hands of people. They just didn't have the time or the skills to do all the data analysis. And that's kind of where we came in. What we were interested in is how do we process this? So we can think about it as like create a structure to empower the team. That's a fancy way of saying spending a lot of time cleaning the data. Also, what's really interesting is that epidemiology has its own sets of tools and processes. Epidemiology comes from very much having a single person working in proprietary formats, Stata, Excel. DataKind is really big on the open data science movement. So how can we use open source data tools like R as a language and work on distributed collaboratory type tools? Distributed version control through GitHub is the most common. Team communication, most people are familiar with Slack. So those are kind of all new tools in epidemiology, and we're kind of modeling how to use those since we're more familiar with those. So speaking of modeling, how do we go from that kind of raw, clean data to actually doing what we think about as data science? How do we fit the right models and find the right meaning in there? The way that we did it was a data dive. You'll hear a lot more about a data dive from DataKind. It's a hackathon, only the thing is it's non-competitive and it's for social good. So also it tends to have not necessarily like a contest with like kind of clear winners. It's kind of more about the process and making sure we deliver something that's of value. But it looks a lot like a hackathon while you're in it. So it's a bunch of people working together on these kind of problems. And this is where we bring together our team of data scientists, data analysts, project managers, and we partner with the organization. In this case, it was Skoll with their influenza data. And then the kind of what unites them is DataKind. DataKind as an organization really tries to bring together data science and these nonprofits. And it looks a lot like data science work. There's a lot of whiteboarding, making mock-ups, writing a lot of code. So all of that stuff that we're in there doing data science. However, that's just one step in that kind of bigger process. So I kind of want to outline and put it in context. The most important thing is we want to make sure that we deliver has value. And value is in the eyes of the consumer or the eyes of the person using that. So what does value look like for the people themselves? In this case, what we were interested in is actually creating a dashboard for health authorities. So people that are administrators, running hospitals, people in the county or federal system, they don't have the time necessarily to look through all these Excel spreadsheets and fully understand it. However, they do have the time to look at a dashboard. And so that's what we did. We took all of this data, we cleaned it, we processed it, and then we exposed it. In this case, this is called an R-Shiny app. So it's a web app that sits on the web, and it's an interactive platform for then health authorities to then explore that. And so then they're better able to understand the flu and what's going on with them in a kind of interactive way. For them, this is like remarkable because for them, state of the art is kind of static graphs. Having something that's interactive and updates is pretty amazing. This also allows them to drill down so they can actually see what's happening local to them, not only what's happening across the country. And the most important thing is, how does this happen over time? So over time, how is flu trending? Are we going up? Are we going down? Should we look at the first derivative, the second derivative? All that information is available then to health authorities. So it was a pretty amazing project that we were able to do. And this is kind of just how we approach this problem of making sure that we ask the right questions. We already were lucky on getting the data. Sometimes that's the biggest challenge. We were able to clean and organize that and have the right systems and people in place to make sure that that happened. And then we were able to model that. In this case, it was a relatively simple model, but it was very valuable for them. And so we were able to deliver that value. One thing I want to say, I made it sound simple. I made it sound kind of clear, because that's how presentations go. Turns out that life is nonlinear. It doesn't turn out this way. Usually it's all of a sudden, oh, you made a mistake. You have to go back and ask somebody something. You have to oh, you realize you don't have the one script that you need. You have to go back and get that. So even though I kind of laid it out that way, we bounce around quite a bit. But it's fun. Thanks. So I have time for questions? Okay, sounds good. Sorry, you first.
How often do you do data dives and setup?
Not often enough. So we've done a couple of them, and we're working on having them happen more often. Signing up is easy, though. You can just go to DataKind.org. I thought just making sure. And then right there, and we're the SF Bay Area chapter. Get on our mailing list, and then we'll update you with whatever events are happening. Great. Yeah.
I was wondering about the adaptive workflow too.
Mm-hmm.
This has a great situation when you walk in and you're working on a difficult strategy for, but
Yeah.
sometimes when I work, I'm basically handed data.
Yeah.
And,
So then go back. Then I would go back and ask. I start asking, why do I have this data? What is it? What's the goal of this? What does it look like to be successful? So just because if you get stuck and you think you're just supposed to be doing just the modeling, or if you get stuck and you're supposed to be just doing the data janitorial work, I would try to put it in a context and maybe understand it that way. But yeah. But the most important thing is also, the nice thing about this is always make it clear that your job is to deliver. Because oftentimes data scientists might be criticized that we love the modeling, so we just want to fiddle at step 4. So it makes it nice when you lay this out and be like, no, I'm going to deliver something. The fiddling is necessary to get to the delivery step. So that way it helps people get buy-in that you have a goal in mind, even though you might change your mind. Cool. I'll be hanging around in the back.